You can't tell me
That's not right.
Admit it, you did not know that already.
Okay, if you guys can turn to page 8 in your packet. Okay, so today we're just going to be working with the same concept as yesterday. We know that vector is a quantity with direction and magnitude. So we're just going to be working our way around our graph, and we're just treating it like as if a person is, walking to a destination from one point to another. Okay. All right. So Harry Potter needs to make a few stops around Hogsmeade. Harry's broom is broken, so he must walk between the buildings. The town is laid out in square blocks, which makes it easy to give directions. Here are the directions Harry must follow on Monday. So let me just, I'll put the compass here, so make sure that we understand. So east, west, north, south. Okay, so east is to the right, west is left, north is up, and south is down. So we're going to start at, here's our starting point, Hogwarts. And we're going to go 3 blocks east, 5 blocks north to reach stop number 1. So, which is counting 3 blocks east and 5 blocks north. Okay, put a 1 next to that. And then we're going to draw the route of Harry's trip on the grid below. Label each of Harry's stops. And how would his trip change if he were able to ride his broom to his 3 stops, going the shortest route possible. So, and then we'll draw this in a different color, but I'll use my pen for his path on the ground. Stop 2. From here, we're going to go 5 blocks east, 2 blocks north. And then from stop 2 to stop 3, 2 blocks east, 1 block north. Okay, so in red, I'm going to highlight his path if we were able to go take the shortest routes. So facing the hypotenuse here. Okay, so the blue would be indicating his path on the ground, and the red would be indicating his path if he were able to travel on his broom. Okay, so we'll come back to okay, eventually we're going to be, now let's go ahead and get this part done. Let's see if we can figure out how far his trip is going to be, walking versus if he were traveling through, if he were on his broom. So we just count the number of units, right? So 3 plus 5. Sorry. 5 blocks east, 2 blocks north, 2 blocks east, 1 block north. So if his walking distance would be 18 blocks. But his travel using a straight path would be a lot quicker, right? So Pythagorean theorem, we know hypotenuse is square root of a squared plus b squared. So square root of 3 squared plus 5 squared would be square root of 25 plus 3, sorry, plus 9, which is 34. Okay, so imagine Pythagorean theorem, a squared plus b squared equals c squared. 5, so 25 plus 4 is 29, square root of 29. And then 2 squared plus 1 squared, 4 plus 1 is 5, square root of 5. Okay, if I were to use my calculator here, just to get some, should be a lot shorter path. Being able to take the hypotenuse. So travel directly between each of those destinations would be 13.45 blocks in total versus 18 blocks if you were to walk in horizontal and vertical path.
34 and 29.
Okay.
How'd you like those square roots of like 34 from the
Right. So these are the lengths of the hypotenuse of each of the triangles. So you know that c squared is equal to a squared plus b squared. So c is equal to the square root of a squared plus b squared. Yeah, I didn't show the work here. So imagine this was here 3 and 5. So c is equal to square root of 3 squared plus 5 squared. Yeah, so I'm just doing Pythagorean theorem and getting the hypotenuse for each of the triangles here and then adding them up. Okay, on Tuesday, Harry has more errands to run. When he is done, he will meet Ron at the Shrieking Shack, found 3 blocks west and 3 blocks north of Hogwarts. His directions for the first 3 stops are listed in the chart below. Draw the route of his trip on the grid. Use the graph to determine his path to the Shrieking Shack. So same idea here. Okay, so stop 1 is 2 blocks east, 4 blocks north. Okay, 4 blocks west, so west is left. So 4 left and 3 north. And then from stop 2 to stop 3, 5 blocks west. Or in other words, negative 5 blocks east. Again, there I go left, left 5, and 3 down. Okay, so we know that his destination here is 3 blocks west and 3 blocks north onwards. So 3 left. This is the 4th stop right here. So to get to the 4th stop from his stop number 3, he's going to go 4 blocks east and 1 block south. Okay, so these all represent vectors in the sense that if we were to draw a straight line from our original location to our destination, these all act as vectors, and each of these vectors has a distinct length and or magnitude, and also has a very distinct direction. So the next page, we're going to put it together in terms of defining a vector's magnitude and defining the vector's direction, which is what we did yesterday. Just here it's in the form of word problems and tasks. Sorry, what I should have done was I should have drawn all of these as horizontal and vertical, horizontal and vertical. And then Hedwig is going to be flying over the buildings and actually going to be connecting all the stops in a straight line. So initially, all of our routes were horizontal and vertical lines, but then all the hypotenuse would just be the fastest path. Okay, so it's kind of drawn out for us here. How far did Hedwig fly to get to stop 1 on Tuesday? This is known as the magnitude of the flight vector. Sorry, it got cut off here, flight vector. So we know he's going 2 blocks east, 4 blocks north. This is your A and that's your B. Imagine that is your component form. Right, and again, we talked about how if you have your component form, that's all you need to find magnitude and direction. Right? The magnitude is square root of a squared plus b squared. So 4 plus 16 is 20. If you use your calculator, you can break it down to be 2 root 5. There are several ways to describe Hedwig's direction. We could simply say she traveled northeast, but this is not as precise or accurate a description simply because northeast can be interpreted different ways. It could be 45 degrees, it could be anything between 0 and 90 degrees, right? It's very imprecise. So it's very imprecise. But if we know component form, we can find the exact degree measure. And again, we'll use inverse tangent like before. But we just have to make an adjustment, right? First quadrant, we're safe. Second, third, and fourth quadrant, we have to understand that the reference angle is going to play a role in helping us find the standard degree, standard position, but it's not the exact degree measure. But we practiced that yesterday, and we're just doing the same thing today. Okay, B over A, so 4 over 2. Okay. My calculator gave me 63.4 degrees. Can I keep it, or do I need to make an adjustment? Keep it, right? First quadrant. This vector is pointing the first quadrant, so there's no changes that needs to be made. Okay, next stop. We might say that Hedgewick flew northwest to his next stop, but it would not be an exact description. What's the possible range of values in standard position that's considered northwest? So northwest is anywhere between 90 and 180. But if I want to say exactly northwest, I would say 135 degrees. But typically northwest can either be exact or it just can be a very general statement like before. Okay, but now we're going to find the exact magnitude and direction from stop 1 to stop 2. So on the previous page, stop 1 to stop 2 is 4 blocks west, 3 blocks north. And so I know that in component form, 4 left, 3 up. Right? I can find the magnitude, I can find the direction, but second quadrant, I had to make an adjustment. I had to involve 180. Okay, inverse tangents, 3 over -4. I got -36.870. I want a second quadrant standard position, so what adjustment needs to be made? Yeah, involve 180, right? Either plus 180 or I can do 180 minus 36.87, but I need a degree measure that's between 90 and 180. Okay, next page, page 10. Find the magnitude and direction of Hedgewick's path from stop 2 to stop 3. So looking back, stop 2 to stop 3, 5 blocks west, 3 blocks south. So -5, -3 is my component form. Okay. Which quadrant would that be in? Yeah, third quadrant. Okay, magnitude and direction. +9. Yeah, our units is in terms of blocks, so root 34 blocks. I get a reference angle, but I need to do what with that? Third quadrant, so plus. Plus what? How do I get to my third quadrant measure? Okay, so finally, from stop 3 to stop 4. 4 east, 1 south. Which quadrant would that be in? Quadrant 4. Okay, I got to negative 14.036, but I need to be in the fourth quadrant, so what adjustment do I need to make? Yeah, 360. It says Ron goes to the Streaking Shack 3 blocks west and 3 blocks north. So 3 west, 3 blocks north. And how does this route compare to the overall displacement of Harry during his errand? So displacement is just where is his initial starting point, where is his ending point? So he went through all that route, but then if we're just comparing that distance from his beginning to his final destination, it's going to be the same as the run that same as the one that Ron took. I'm sorry.
Why didn't you put a degree measurement?
Oh, for this. This is in terms of, yeah, it says direction. It doesn't ask for, yeah, you're right. It can be interpreted as direction in terms of component form, or it could be direction in terms of degree form. So it doesn't specify, so I will specify though on the test, yeah. But this would be like 135 degrees, right? Okay, same as Ron's. Right. The way that we have expressed Harry's routes is known as component form since it is made up of two parts or components that describe the change in the horizontal direction and vertical direction. The way that we have expressed Sedgwick's path is known as magnitude direction form since it gives the distance directly, your hypotenuse, and then the angle measurement. Both will take you to your destination, but it's just given in different forms. Okay, so our classwork is just page 11, and we're just going through and finding each of the horizontal vertical component or the magnitude direction component. Okay, so let me walk you through this, and we're going to see a lot more of this tomorrow, but we have two categories here. One category is where you're basically given your X and Y value. And the other category is, imagine Hedwig or Hedwig, whether just going along that path to his destination, your hypotenuse, and then just traveling in that direction. But your X and Y value is just left in horizontal and vertical.
Each onto the bottom too.
No. Well, no, we'll just walk through A through D. All right, so 6 blocks east, 3 blocks north. I think we're comfortable working from horizontal vertical to magnitude direction, but working backwards is what I want to help us get to. But let's do the easier one first. We know component form, this is 6, 3. All right, this is first quadrant, Pythagorean theorem. Any adjustment needed with theta? Yeah, keep it. Yeah. First quadrant. All right, now we are given the hypotenuse and the angle measure, and we're trying to work backwards to figure out what is the X and Y components. Okay, so we're going 16 blocks at 113 degrees. Which quadrant is that in? Second quadrant. So let's make it 116. So we're trying to figure out what is the horizontal and what is the vertical. So call this X, call this Y. Now for X, I can use cosine, right? Because cosine of theta is equal to adjacent over hypotenuse. And that's going to help me solve for X. So I'll say cosine of theta is equal to X over adjacent over hypotenuse. I can put that over 1, cross multiply. Sorry, no, 16. No, I don't know why I put 116 like that. 16. Make sure you're in degree mode. So we know that this is 6 blocks west, right? And then if I want to solve for y, I can use what? Sine. Sine of my angle measure is opposite over hypotenuse. Cross multiply.
What's the Pythagorean theorem, right? That one?
You're right. That's right. If I have two sides of a right triangle, I can go through Pythagorean theorem. We don't have to go through sine. Yeah, but we do need at least sine or cosine to get it started. But you're right. We can go to Pythagorean theorem after that. Okay, 2 blocks west, 6 blocks south. I'm just going to put it in component form here. This is -2 and -6. Okay, which quadrant? Third, right? What adjustment is needed here? Plus 1/8. Okay, again, working backwards, D is going to be similar to part B. So 10 blocks, 315 degrees, that's in the fourth quadrant. Ten is my hypotenuse. I'll use cosine to solve for x, and then you can either use Pythagorean theorem to solve for y or sine. So what we're going to be working towards is being able to go back and forth, right? So if I'm given X and Y, I can use Pythagorean theorem and inverse tangent to get to my direction and magnitude. But if I'm given direction and magnitude, I can go back and do cosine, use cosine and sine to get to my X and Y horizontal components. So we're going to be practicing a lot of that back and forth, along with more topics and yeah, and concepts later tomorrow. All right, go pick up your phones.